Good morning, all of you. Uh, last time we discussed about the portfolio credit risk. So at the start, we just categorize our risk management into two sectors where we just look at the individual transactions or individual trade transactions, and we can arrive at the risk exposure which can arise from that individual transaction. In order to just arrive at the expected credit loss, or we call it risk, we have really gone through the calculations with regard to some parameters. Out of those parameters, the most important parameter is the probability of default. And later on, then we discuss about the loss given default and the exposure at default. And in the cases of longer term expected credit loss, we need to get the maturity period also. When normally the tenor is more than 1 year. But in case of the calculation of expected credit loss, as per the IFRS 9 requirements or SLFRS 9 requirements, we have to arrive at the expected credit loss under 3 different categories. The first category is the performing category, where we have to calculate the expected loss pertaining to the current year. Now that is with regard to the performing advances. Then there's another category called underperforming. Now underperforming means there's a small risk event which can arise, and we need to just transfer it, or in other words, there can be some type of a issue with their repayments, or their credit quality has gone down. Such category is called underperforming. Then there's another category. Now in the underperforming category also, we have to arrive at the lifetime expected credit loss. Lifetime in the sense, the tenor of the loan. That is what you mean by lifetime. Original tenor, because when we grant the loan, we just agree on a certain tenor. Then when a loan is in that particular category, then if something definite or determination can be done, if that is the case, so we need to just transfer it to the third non-performing category also. Now, there should be a certain credit event which can assure that there's an issue in the repayment, or we call it impairment. So such instances, the loan would be transferred to the non-performing category. There also you have to get the expected loss calculated. That calculation also to be done for the total tenor of the loan, or lifetime we call it. Now these are the fundamental requirements of expected credit loss. Now in case of the individual loans, we just went through the methods of getting onto the individual probability of default, individual loss given default, and the individual exposures. But later we wanted to discuss about the portfolios, because in an institution, portfolios are really important, because as a portfolio, it might behave in a different manner than individual loans. So in one side, we can say that when there's a portfolio, the total risk of the portfolio would not be, if you take the algebraic total of individual loans, invariably that amount is higher. As a portfolio, the risk could be less. Now that comes through the diversification effect, because you all know when you talk in terms of risk, whatever it is, credit or what, there can be market level risk, or we call them systematic risk, and the other type is the non-systematic. Now in a portfolio, non-systematic risk could be compensated. Yeah, you might have risk with some companies, but the other company, they don't have a risk on those lines. So in such a case, when you have a portfolio, the portfolio might have a total risk which is less than the addition of all the risk individually. So that is one advantage of a portfolio. But in a situation where several correlations take place, then invariably the portfolio risk will go up, because this portfolio risk, the control or the reduction mainly depend on the correlation between each loan in the portfolio. If these correlations are negative, then we get the minimization of risk in the portfolio. So that's we can say that we call it is the 100% diversification effect. But in an economic downturn, it may not happen in that manner. In an economic downturn, what happens is, though the correlations are not so high or negative correlations are there between the loans in a normal situation or in a boom situation, but in a downturn, these will become positive and intense. So in such a situation, the portfolio risk will go up drastically. I think those things we discussed last time, and we went into some type of calculations also. Now today, we will elaborate on that, and we will try to explain the credit value at risk. So these are the lessons we are going to start today. We are going to discuss today. Now this presentation we discussed last time, and I want to just highlight several aspects in that presentation for your information, where you can analyze certain things by getting that knowledge. Now just look at this graph. Now this graph is a indication of how the EDF and percentage loss per unit of average exposure makes a relationship, the expected loss. Or in other words, for different EDF and exposure default figures, how can the expected and unexpected loss vary? So that is the explanation I'm trying to just convey through this graph. Now just look at it. Now when EDF comes along the x-axis, percentage loss per unit of AE means, now this is a particular parameter very much parallel to the exposure at default, but it is given in a unit form. But anyway, there's no big issue here because percentage loss per unit means LGD as a percentage. That is what it means. So this is the expected loss when EDF increases, percentage loss per unit of A increases, expected loss increases, but it increases along a straight line. So there's you can say proportional increase. But when you go into unexpected loss, it has an exponential increase. Now you can see EDF just have a higher figure. So a small change of EDF happens, and there will be a very high change of unexpected loss. Now you can just look at this graph and see. Now I am at 0 now. The cross comes to 0 now. When I go just along the EDF line, and if I come to this point, now you just see what is the corresponding unexpected loss. It is somewhere here. So you can see even the expected loss would not come into that levels even when the EDF is very high. So you can see for a small change in EDF, there will be a very, very drastic change in unexpected loss. So this is the point I want to convey here. So then we need to quantify these things at a portfolio level. At a portfolio level. So last time we discussed about portfolios also, and then we just went through a formula where you can get the portfolio probability of default. Portfolio probability of default. So that is an important formula. Through that formula, you are in a position to get the portfolio probability of default. But there are several limitations here. Now that portfolio probability of default is calculated on the basis of correlations between each loan. And we denote it as rho, the correlation factor. And there's another factor we are looking at. That is we call it confidence level. The confidence level means you can just give a level. You can assure that the particular loss will not go beyond a certain level at that confidence level. So we go into the formula and just look at it. You look at this formula, and later on I just told you there's a particular Now this is the formula. Now this is what you call the worst case default rate. Worst case default rate. Now this the particular term worst case. The worst case means this is the maximum you would expect at a particular confidence level. Now the confidence level is given by X, capital X. And we call it the versus X model. And today we will have a idea about the credit value at risk, which can be connected to this formula. Now T and X represents the period and X represents the probability of default. Or and it's a normal confidence level, so we call it our confidence that the PD may not go beyond a particular amount at this confidence level. Now, when you work out different issues, problems, you will get to know more about these things. I think we last time also we went through some problems, but this time also we are going to have more elaborate type of explanations on that. And first of all, now you need to have a good idea about this formula and the denotions of this formula. Now you just look at it, and N means you have to get the value within these brackets, and you have to just look at the normal curve tables to arrive at that value. N minus 1 means you have to look at the value and you have to see in which position it is in the normal table. So then you have to look at that position and see how you can arrive at that position. So that is what you mean by N minus 1. So we call it inverse normal curve. Inverse. We call it inverse. I think these terminology is important. So therefore, you just be familiar with these notations, and you are when you are in a forum also, you need to just explain these things sometimes. So therefore, you have to just understand the vocabulary with regard to these things, and we call this the inverse normal curve. Inverse normal curve of EDR. So that's what it means by N minus 1. And if you just find out the WCDR or worst case default rate, and we are in a position to calculate it for individual loan. Individual loan. So, and I told you last time, this gives the unexpected loss even. When you calculate this, you can get the unexpected loss also. Not only the expected loss, unexpected loss is also being taken. So, but the issue is, we can calculate the expected loss. And if you calculate the expected loss of an individual loan, and if you want to get the calculation of total portfolio's expected loss, then what we are going to do? We have to add up all the expected losses together, and you will get the expected loss of the portfolio. But in the case of unexpected losses, that thing you can't do. But if you have a large portfolio of N loans where each loan is a small part of the total portfolio, the X percentile of the loss distribution is approximately this one. So that is the, you have to take all the loans, and each loan's worst case default rate to be determine, and then we have to just apply it for all the loans. Now we will go into the credit value at risk explanation. Provided there is a single row where WCDRI TX, or we call it worst case default rate, EADI and LGDI are the values of WCDR, EAD and LGD for the ith loan in the portfolio. Now I think since these things are little abstract, you have to be little careful and you need to be vigilant on these things, because you have to concentrate on this in order to understand this. But though apparently it's a very complicated type of thing, it is not that complicated. But if you have a good concentration, or if you have a good vigilance about what we are talking here, so then you will not just get into a situation where you might think these things are so complicated, but it is not so. Right. Anyway, now just look at these terms. WCDR-ITX, the meaning is, that is the worst case default rate of ith loan of the portfolio for a time of T years and for a confidence level of X. EADI is the exposure default of that particular loan, and LGDI is the loss given default of that particular loan. Now we are trying to just give a certain calculation for the regulatory capital. Now, normally the capital for a bank is the purpose of having capital for a bank is to just deal with the unexpected losses. But here we say it is regulatory capital, but regulatory capital also, the regulations also compel the banks to have it. Now, how do they estimate that? They look at the particular portfolios and see what would be the unexpected loss they can expect. So we can't say expect, because since it is unexpected. So that is why we take it as the worst case. Because the worst case means it is unexpectedly which can happen. Worst case. Even unexpected happens, it may not go beyond worst case. That is why we take the worst case as the unexpected loss. There we try to get the worst case default rate. Worst case default rate. So when you calculate that worst case default rate and we multiply it with the EAD and other LED, then you will get the unexpected loss of the particular loan. But now there is an expression. Now in that expression, what happens is, you have, I show you again. Now this is the sigma I equals 1 to n, means you need to get WCDR 1 into EAD 1 into LGD 1 plus WCDR 2 into EAD 2 into LGD 2. Likewise, you will have several loans to, you have several portfolio defaults, several loan defaults, or in other words, we call it worst case default rates for each loan, each and every loan, and you need to get EAD for each and every loan and LGD for each and every loan. So that is the methodology to calculate the expected loss, unexpected loss. But in a scenario where the downturn is so severe, we can just say all the loans will have a same worst case default rate. All the loans will have the same worst case default rate. In what a situation? It is the situation where the downturn is so severe. And not only that, there's another thing. All the loans will have a correlation of a particular value, say rho, for each and every pair of loans. These are the conditions. These are the conditions at which we arrive at credit value at risk. I will come back to you again. Now it is like this. Now you have the worst case default rate for individual loans, and you have EADs for all individual loans and LDDs for each individual loans. But if you talk in terms of a situation where all the loans worst case default rate would become the same value, in what a situation? It would happen when there's a severe downturn in the economy. When there's a severe downturn in the economy, it can happen. So then we can say that all the loans will have a similar worst case default rate. So that is one condition. What is the other condition? The other condition is that every loan will have the same correlation coefficient. Because say you have 10 loans in the portfolio, and you have, now when you have 10 loans, you will have how many pairs? 45 pairs you will have when you have 10 loans. It is another good thing to learn. Now say in a portfolio, if you have 2 loans, how many pairs are there? 2 loans, only 2 loans, only 1 pair. Say AB, only 1 pair. That is AB. When you have 3 loans, how many pairs you can have? You will have 3 pairs, AB, BC and AC. When you have 4 loans, how many pairs you will have? When you have ABCD, then there are 4. How many pairs you will have? You will have AB, you will have AC, you will have AD, then you will have BC and CD. So likewise, you can get several number of pairs. So can you tell how many pairs you will have for a 4 loans portfolio? You will have 6 pairs. You will have 6 pairs. Now you will wonder how you can arrive at this number without much problem. There's a formula for that. There's a formula for that. Because it is necessary for you to see how many pairs will be there if you have so much loans in the portfolio. Now in a portfolio, there can be a number of loans which can be any number. Say 100,000, 100,000, 150,000. Likewise, there can be several figures which you can say for a number of loans in a portfolio. So, but it is not the only thing you need to look at. Then you need to see how many pairs will be there. How many pairs of loans. So that's a very important information you need to get. Now you can see in a downturn, what will happen is for all these pairs, you will have the same correlation. You will have the same correlation coefficient. So that is the other condition. Now, what are the conditions now? In a downturn or severe loss situation, unexpectedly, what will happen? for a portfolio, the probability of default will be same for each and every loan in the portfolio. This is one condition. The second condition is if you have n loans in the portfolio, n means any number, and then it can create any number of pairs. For each pair of those loans, same correlation coefficient is applicable. That is the second condition. Now, if you look at these conditions, you have everything to realize that it is the worst case loss or unexpected loss. And we give another name for that. We call it credit value at risk for the portfolio. Credit value at risk for the portfolio. Now we can do some calculations and see what are these, how are we going to calculate these things. Now when you go to the next one, then we call it copula correlation because with each couple, you have the same correlation. If the horizon is greater than 1 year, the expression B has to be multiplied with maturity adjustment. Now that's what I told you earlier also. Now, basically we calculate these things for 1 year. If not for a 1 year, it can be 2, 3, 4 years like. So if that is the case, you need to multiply the factors which we already studied with another factor called MAI, that is maturity adjustment. Now banks can have their own estimate for this rho. Rho is the correlation coefficient between the pair of loans. And it can be, now in this particular presentation, now you can just see rho for 2 company loans should be approximately equal to the correlation between the returns of the assets of the companies. And this is roughly, this is the same as the correlation between the returns of their equities. Now, these can be calculated through the information which you can gather from the stock market. These are practical situations. So, say, for example, if you have several loans in a portfolio and all the loans borrowers are companies, say quoted companies, if they are quoted companies, you can get their returns, asset returns calculated, or their stock returns. And when they have the stock returns, you are in a position to calculate the correlation between these two returns. And that is the correlation you need to apply for your loans there. So this is a type of a practical method you can just apply in order to get the correlation calculated of the particular loans. In a downturn, what happens is all these correlations will become similar. So that is what you call downturn correlation. Now just look at it. When worst case default rate for the portfolio is calculated, it is assumed that the correlation between any pair of companies in the portfolio is a value in the range of 0.5 to 0.5 to 1. Now, the correlation coefficient can take values from -1 to +1. It should lie between these two values. But in the case of our downturn correlations, it may not be minus, but it should be 0.5 to 1 because it should have a substantial value in a downturn. So that value is very much higher than or just higher than 0.5, and it can go up to 1. Higher the correlation, more severe the downturn. So depending on the downturn, severity of the downturn, you might record or you might arrive at a portfolio correlation or copula correlation. What do you mean by copula correlation? Copula correlation is the correlation between two loans, a couple of loans. That is what you mean by copula correlation. Now, copula correlation will be, coefficient will be 0.5 or more, up to 1. In normal economic conditions, PD of each loan is similar, and it can be considered as the portfolio PD, and the value is close to 0. In a normal situation, in a normal economic situation, the PD is very small, but the PD is similar for a portfolio. Now, there are reasons for that. One reason is more or less all the loans in the portfolio you can see, you can review and see more or less the same risk grading. Now, if they have same risk grading, theoretically, they need to have the same PD. But in a normal economic conditions, this PD is a very low value, and it is very close to 0 in a normal economic condition. But what happens in a downturn? The value will go up drastically. Portfolio expected loss. That is, you have to have the portfolio PD, portfolio EAD, and portfolio LGD. Then unexpected loss, you have to have the worst case portfolio, worst case default rate for the portfolio, and you have to deduct the portfolio probability of default, normal portfolio probability of default, and this is the worst case probability of default minus the portfolio probability of default. You have to multiply it with portfolio EAD and portfolio LGD. Then you can calculate the unexpected loss. Right. Now, these things, we can now see how we can arrive at these things through a through a problem. So we can have a problem on that. Yes, anything you can we can have a conversation on these things or discussion. What do you think? What do you say? Yes. Because this is important and this is practical also. So therefore, I think you to put your attention to these things. And if you have anything to clarify, just you can ask questions. Yes. Before going into the problems and examples and all, so if you have anything, because I just talked with regard to some say concepts. Those concepts are very important or very necessary for your practical applications. If you have these concepts, it is very easy for you to apply those things in a practical way. That is why I need to just activate some discussion or active discussion regarding these things. If you don't ask questions, then I don't think that this can be clearly understood. So therefore, better it is for your interest I am telling these things. So just clarify anything if you have any issues here, because these things are highly scientific, and in the world there have been several research towards these areas, probability of default, loss given default, and this portfolio losses and all that. There have been several research done on these things, and then it is very scientific. But if you don't do any thinking, and if you don't have any regard for these concepts, then there's no value of this research or anything. Now, the requirement, the ultimate requirement is to look at these things, analyze these things, and see how we can safeguard the institution and its long-term stability. So these are the ultimate objectives of doing these things. You have to safeguard the institution. You have to just have a steady growth for the organization and all that. In order to just achieve those things, you have to understand this and you have to apply the concepts. Right. Any questions on this? And I just want to give you a certain type of that can be an exercise. Say, I can tell you the way you can do the calculations to find out the correlation coefficient between two companies. Now in Sri Lanka also you can do that. Say you just select two companies quoted in the stock exchange, Colombo Stock Exchange, and you can get the information with regard to their returns. Through those information, you will be in a position to calculate the covariance and then correlation coefficient. So if you do that, then you can apply those things into a portfolio. Any questions? Don't take the things which I say as correct, all the things. I mean, you might not understand what it is, but if you ask questions, you can understand. Yes. What do you want to just clarify or if you don't have anything to be clarified, then I will go into the working of sums and all that. But I really expect that you all will have an attentive type of a session. You don't put your attention here, then I don't think that you can get anything from this. But you need to actively engage in these things. Right. Now I will just give you a particular sum. I don't know. Last time we just went through the sums and all. Uh, anyway, we will just go into a problem and then Now I have just put a example on the board. Suppose that a bank has a portfolio of housing loans with 100 million total exposure. Each loan's contribution in the portfolio is negligible. If all the loans have a similar default frequency of 1.5 and a copula correlation of 0.6, number one, calculate the worst case default frequency at 99.9 confidence level. Number two, what is the credit value at risk of the portfolio if the recovery rate of the portfolio is 25% at a 99.9 confidence level? Now, this is the, we can put it as an exercise and I will explain it, how we can do it. So, I am just giving you the instructions, how you can work out this sum. Now, you all know there's a formula. There's a formula for the worst case default rate, WCDR. And really, there's another thing we can say for a horizon of 1 year. So, all these things to be calculated for a horizon of 1 year. For a horizon of 1 year. Right? So, the first thing what you need to do is, you need to calculate the worst case default rate at a 99.9 confidence level for a horizon of 1 year. Now you can use the Wasisek model, WCDR, which would be equal to N. Then you have, I think I can just show you the particular formula. As per that formula, so you all know how to do that, how to arrive at that, how to calculate using the formula. N within brackets, you have to have inverse normal curve of EDR plus square root of rho into inverse normal curve of worst case probability divided by square root of 1 minus rho. So applying that formula, you will be in a position to get the worst case default frequency or default rate calculated. So just I will put that formula on the board. Now, if I put the formula on the board, you should be in a position to calculate and just come up with the answers. So I will put the things into the formula. WCDR Tx is equal to N minus inverse N EDR plus square root of rho into minus X divided by square root of 1 minus. Now this is the formula. You can't see that. Right, this is the formula. Now you can apply the formula to calculate the WCDR at 99.9 confidence level. Yes. Now you can just apply the values given in the sum for this. Can you just do it? And you can see how you can do it. Now here you I will write those things in big letters. Right. Now you need to just apply the values here in this formula and just see what is the WCDR or worst case default rate of this. Just do that. Now ER is given here. It is 1.5 default frequency, 1.5%. And rho is also given. It is 0.6. So with that you will be in a position to calculate this. I will put the values and just show you how to do it. So then you can just look at it and see what is it. Now you see n inverse normal curve, EDR is 1.5%. So therefore you can put it as 0.015 plus what is square root of rho? That is square root of 0.6 into n minus 1 0.999 divided by square root of 1 minus 0.6 is 0.4. Right. Now you need to go into the normal curve tables to look at this. Come up with those values. You have the normal curve tables with you. So then what you need to do is you have to get the inverse normal curve values. For that you need to see where this figure is located. 0.015. So I will come up with the figure. In the meantime, you also can look at it. Then here also you have to get the inverse normal value of 0.999. 0.999. just to do it. I mean, you can just go to the normal curve tables and do that. Right. Can anyone tell me what is the value for 0.015, the inverse normal of 0.015? Inverse normal of 0.015. These things are important. Now, in the examination also, you might have to do this type of calculations. Now, you can find this figure exactly on the normal curve table. Exactly on the normal curve table, you can find that. Where it is. Now, you can locate it. Now, when you locate it, you can see the row number. In the row, it is minus 2.1. And this, the column is 0.07 column. So, therefore, the answer is minus 2.17. So, inverse normal of 0.015 is minus 2.17. I don't know whether you got it. Have you been able to got it? Have you been able to get it? I am referring to the inverse normal value of 0.015 and it is 0.0150. Yes. In the normal curve table, you just look at it. Just look at it on the normal curve table. Now, this is the value you need to check. That is minus normal value of the 0.015. 0.015. Yes. Yes, 0.015. Has anyone found it in the table? Yes, if you go to the table, you will see that it is located. You can locate and you can have the same figure, very fortunately, because rarely it can happen. You always get a get a figure which is close to that value, not a value, the same value, but here you get the same value. So that's a fortunate situation. So now when you locate it, you can find the row now. In the row, it is minus 2.1, and in the column it is 0.07. So therefore the answer would be minus 2.17. Minus 2.17 is the answer. So that is, you can just put the inverse normal curve of 0.015 is minus 2.17. Minus 2.17. Then the square root of zero.6. Square root of 0.6. What is square root of 0.6? That is 0.7745. So you can say for 0.7746. 0.7746 is the square root of 0.6. 0.7746 into, then you get the inverse normal of 0.999. So there also you can see the figures. 0.999. Yeah. 0.9990. Yeah, it is there. But you can find it many places. It is in the 3.0 row and 3.1 also, but I think you need to get the minimum value. So you can say 3.08. 3.08 is the value. Yeah, 3.08 is the value. 999. And divided by square root of 0.4. So what is square root of 0.4? That is 0.6325 or 6324. Now you have, when you can get the minus normal curve value of 0.015, you get minus 2.17. And you get the value of square root of 0.6, you take it as 0.7746 into inverse normal of 0.999 would be 3.08. And in the denominator, you have square root of 0.4. That comes to 0.6324. 0.6324. Now we will simplify this. Can do the simplification calculations and just get what is the value within this bracket. So anyone can come up with that value. Now you get the value inside 0.3412. Point 3412, but you need to have only three decimal values, so you can say it is similar as 0.341. Now, how do you look at it? Now, here you have to get the normal curve value, not the inverse normal. You have to get the normal curve value. So, what is that? 0.34, 0.341. 0.6331. Get the value as 0.6331. Point 341, you can just get it as 0.6331. So you can see the worst case default rate will be 0.6331, that is 63.31. 63.31. So when you say 63.31, that is a very high probability of default. So the answer for the first one, that is worst case default rate, WCDR, is equal to, this is 99.9 confidence level. It is 0.6331, that is 63.31. Is the probability of default. So that's a high probability of default. Right. Now, the first of all, calculate the worst case default frequency at 99.9 confidence level. So the answer for that would be 63.31. Yes. Now I just put you the this formula which can be used, and I just do the calculations also for you. But what you need to do is you need to follow it, otherwise you can't get it. And try your best to do it practically, and you just go to the normal curve tables and get it done. Now, since I did the calculations by using the formula, so I just put the formula on the board, and then I just put the values also there. And after putting the values, I just arrived at this value. The value is the worst case default rate of the portfolio, that is 63.31. So that's you can just check that and see it's a high probability of default. 63.31 is a very high probability of default. So the second part shows that what is the credit value at risk of the portfolio if the recovery rate of the portfolio is 25%. Now, when you look at the credit value at risk, the meaning is your loss, the highest loss or worst case loss of the portfolio. But if you have been asked to calculate the unexpected loss, it is not the answer. But this answer you can get from looking at the credit value at risk. Now I will show you the calculation of credit value at risk. Credit value at risk of the portfolio at a 1 year's horizon for a 99.9 or 0.999 probability of default equals to WCDR 1.999 into LGD. Now here the recovery rate is given as 25%. Therefore, the LGD would be 0.75 into EAD. EAD is the exposure at default. Now, exposure is the total exposure of the portfolio, that is 100 million. And WCDR is 0.6331 into 0.75 into 100. These are substantial figures, so we will see what is that figure. You get the value as 47.48. Is millions, million. $47.48 million. That is the credit value at risk. So yes, sir. Now you can see, if you look at the portfolio is 100 million. Now out of that 100 million, if you lose 47.48, that is very close to half of the portfolio you lose. That is what you call the credit value at risk. So that is the maximum loss you can make at a 99.9% confidence level in the portfolio. So such values we call the value at risk of the portfolio. Make sure that you just take it down at least, because it is a practical workout of a sum. You have any questions? Any questions on that? Yes.
Excuse me, sir.
Yeah.
In this example, the
Yeah.
frequency is given as 1.5%. If we
Yeah. Yeah.
apply to
Yeah.
our portfolios, how can we find this frequency?
1.5%. Yeah, that is taken as in the decimal form. It has been taken as 0.015.
No, in practical,
Yeah.
if we apply to our portfolios, how can we find this that frequency level?
Right. Now, what you're asking is now in a real life situation, how you can get at the portfolio. No, that's what you're asking, no?
Yes, sir.
Right. No, it's like this. Actually, now that particular explanation I did at the earlier stages, but anyway, since you have asked that question, now it's like this. When you go into a portfolio, basically that portfolio is a homogeneous one where all the loans are in similar category in the normal portfolio. Say, for example, you have now in this portfolio also, I said that this is a housing loan portfolio. Now, when you say it's a housing loan portfolio, basically the portfolio, all the loans in the portfolio are given to a certain category of people. Say, their income levels and all that may be similar. And their backgrounds, their social status may be more or less similar. And if you go into details, say that in your bank you might have a rating model or rating system where you can rate your customers. If you get the rating of the portfolio's customers, you will find all the customers, maybe about 90%, more than 90%, would have a similar rating, same rating, same credit rating. Now, what do you mean by same credit rating? Same credit rating means they all will have same probability of default, because the credit rating has a uh, what you say, the identical type of a probability of default. For example, say when you have a rating migration matrix, there you get all the probabilities of defaults of the grades. Now you have double A, triple A, triple B, double BB, and so on and so forth. For all these gradings, you can arrive at the probability of default. So such probability of defaults are taken as portfolio probability of defaults. Now you get the meaning. Only thing is now in a very real life situation, you may not come across this type of things. But as an estimate, you will get that way. Now say there can be situations like that. Basically housing loan, then you might have vehicle loans, or you might have say semi loans. Now you get a particular category. The whole portfolio can be taken into a one risk grade. if that is the case, all the portfolio loans are in the similar probability of default. So that is the underlying rationale behind that. Is that clear?
Yes, sir. Here the frequency means PD, no probability default.
Yeah. Frequency means the probability of default. Yes. Because
Okay.
now it's like, now that's a good question. I mean, expected default frequency, EDR we call it. So that is, though we can say it's a different figure, but it goes to the same, because when you go into expected default frequencies averages, say you go through for a 10-year period and you get the averages of EDR for all the 10 years, and that is what you call the probability of default. But you can't say it is 100% equal to the probability of default, but it's an estimation for probability of default or proxy for probability of default. So that is how you go into that. Even in risk categorizations, risk gradings will have an identical probability of default. So those things are also not 100% accurate things, but we can take it as an estimate. So that is, now everywhere you find this type of credit estimations, so all those are estimations. Can't have 100% accurate type of things. Even now, your question is very valid, and because you need to have some idea or some reasoning about these things. That is why you asked that question, no? Right. I think I appreciate your question, and I don't know whether you got my point.
Yeah, it's clear, sir. Thank you.
Right. Okay. Now we can go into the question, and there we do the calculations, and we arrive at a certain figure. It is also the probability of default, but it is not a normal probability of default. It is the worst case default rate. Worst case at a very severe economic downturn, the portfolio will have a very high probability of default. That is what it means. Now you can just check the values you got, and that is 63.31. That is a very high probability of default. So therefore, when you apply that into the portfolio, you will get the credit value at risk. And I think under market risk, you should come across this type of things. And what do you mean by value at risk? It is the risk or the loss you that is the maximum loss you have at a confidence level for a given horizon. Now, in this particular instance, the horizon is taken as 1 year. So, for 1 year horizon, at a 99.9 confidence level, the probability of default will be 63.31. So that means that is the highest ever probability of default which you can think about. So you are 99.9 certain that it would not go beyond that level. That is what it means. I think that concept is very important, because the value at risk concept we have already used in hello. Oh. Make a part. Oh. So that is how you can go into the values, and after calculating the probability of default, the worst case default risk or whatever default rate, then what we did was we just applied to the loss calculations. There you have the WCDR into loss given default into the exposure at default of the portfolio. Now here it says in the sum, it says it is 25% the loss given default. The purchase price for a bond that is paying 8% per annum coupon payment semi-annually. මේකේ මේ value එකක් දාලා නැහැ. හැබැයි ඒගොල්ලෝ ඒක මෙයා කරන්න ඕන. assume කරන්න ඕන. අන් එහෙම තමයි කියලා. Right. Now you just find that the value, credit value at risk is 47.48 million. So that's a substantial portion of the portfolio. So it's about half of the portfolio. Like now, if a bank has this type of a loss, I don't think that the bank can survive. So that's a big issue. When 100 million, say $100 million, say 47 million loss of one portfolio, I think it's a very unbearable type of a loss. So that is what we can understand. So therefore, now we can get an idea. Now as the questions been asked, so whatever it is, you do these calculations, and as estimations you do these things, and you have to be careful when you look at these things, and you have to keep in your mind that there have been several assumptions when arriving at this figures. Right. Now, I can give you some additional ideas here. Though we take the credit value at risk as the total figure, say, for example, if you look at the portfolio, and in a normal scenario, the expected default frequency is only 1.5%. So if you want to get the expected loss calculated there, what is the expected loss? 1.5% into 0.75 into 100. That would be the expected loss for the portfolio. So that figure will not be a big one. So I can just give you the figure. What is the figure? 1.5% means 0.015 into 0.75 into 100. Now you see the expected loss as a very, very small amount comparing to the credit value at risk. The expected loss is only 1.125. That's a small, very small amount. So this is what you call the expected loss. So therefore, if one wants to get the unexpected loss also calculated, so what you can do, you can get the total value at risk, that is 47.48 minus 1.125 will give you the unexpected loss. So that is also a high portion. Now you see, if you take the probability of default, now normal probability of default and calculate this, and you will get a very small figure. But whereas when you calculate get the worst case default rate and do the calculations, you will have a big figure. The difference between these two will give you the unexpected loss of the portfolio. So these are normally, now say, if a bank wants to provide capital for their portfolios to be in a safer position, so what they should do is they should calculate this worst case probability of default and come into these unexpected losses calculated, and the value has to be set aside to to act as the capital. So that is what normally the banks are doing. I think I have just tried my best to put you onto that particular thinking pattern. Now I am just asking you, if you are looking at a credit portfolio of a bank, what are the types of concern you have? So you have to be mindful about the indicative type of correlations between these loans. That is one part. The other part is the situation of the economy and how will affect your portfolio, and what are the additions to the portfolio or the trends where the particular borrowers normally face with. Now, these things are very important for a for an officer who manage a portfolio. And not only that, that particular person has to have a good idea about the rating profiles of the portfolio loans. As I told you, now I think you have a confusion with regard to the probability of default. So that confusion also can be sorted out with the idea that you have a very good idea about the ratings of your portfolio. So if that portfolio is a homogeneous one, invariably your probability of default of each and every loan of the portfolio might be the same, because all are in the same rating category. But there can be situations where in a portfolio, very less number of loans can go into other risk categories than the maximum level of loans in a certain rating category. But that can happen. But anyway, in a homogeneous portfolio, maximum or very high number of loans are in one rating category. Therefore, we can say approximately our thinking is correct. So thinking is correct, and therefore we might get approximated type of answers from that. That is what I can tell you. Anyway, we can have a break and just start by another 15 minutes, right? By 10:30. Come back to the session. And we can go into little detail with regard to this portfolio risk and how we can apply these things into day-to-day credit management activities. So here the things are, you can just briefly say that the idea behind these things would be we need to have some quantifications on the expected losses, unexpected losses, worst case losses, and the provision of capital and that type of things. In addition, we need to have an idea with regard to the relationship between the economic state or economic situation and the probability of default of the loans in a portfolio. Not only that, the LGD also is an important factor where given default also has a connection with default probabilities. So therefore, these things will have a basic importance, but at the same time, people should have a good idea about these quantitative activities. And this quantification gives you a certain convenience, because though we think that it involves several mathematical methods, several symbols, several codes, and all so and so forth. Even though with all that, the things being really rationalized and simplified. So that rationalization or simplification cannot be underestimated. So therefore, you need to appreciate these methodologies which have been invented by several financial analysts in the world, and Actually, these people who invented this type of things been awarded with Nobel Prizes and all. For example, Robert Morton and Basisek and all these people were really rewarded with especially the Nobel Prizes, Nobel Prize for Economics Theory and all that. Those people were really rewarded. And they have just served the society. Why do we say serve the society? Because the credit risk management of an organization, uh, the bank and all, it really assures the stability of the organization. By assuring the stability of the organization, it assures the systemic stability. By assuring the systemic stability, it really assures the stability of the economy. And it will assure the people's well-being. If some economic downturn takes place, it will really affect the people's lifestyles, livelihood and all. Therefore, it's a real service to the society to uh, have these safeguards. Not only the safeguards, how we can deal with these crisis situations. All these are new knowledge. So then we have to appreciate that, and at least we should understand what it is. And the concepts you need to understand, and then you will be in a position to make use of these things. Okay, now as it is, now the things which we already did, we just stopped with credit value at risk, but I can further ask questions on this same problem. And the last question would be, what is the unexpected loss of this portfolio? When you say the unexpected loss, how are we going to do it? So we have calculated the value at risk. Value at risk means the highest loss we can make. But within that, you have the expected loss. If you just deduct the expected loss from the total value, you will remain with unexpected loss. So that is how that unexpected loss been calculated. So I think I can add that part to the question. Now, further part I just added to the question. Now just look at it. The third part. Calculate the unexpected loss of the portfolio. Unexpected loss of the portfolio. When you say unexpected loss, I told you how we can calculate it. Now we have already calculated the credit value at risk, and that comes to 47.48. Now, how are we going to calculate the expected loss now? So you have to go to the normal probability of default of the portfolio. It is not the worst case, it is the just normal case, the regular case. So it is 1.5%. And all others, say LGD and the EAD would be same. There's no issue with that. We assume that LGD also the same. So if you assume that way, we can have the expected loss calculated. Just try to calculate the expected loss of that thing. Yes, you got the value for expected loss. Yes. I think this is a simple one, but if you do it, that's good for you. You just develop some skill. Just make sure that you got the answer. So probability of default, normal probability of default is 0.015. Then LED is 75.75, and into the value of the portfolio is 100 million. So what is the value you get? It is 1.125, is it? Because it's a multiplication of 0.015 into 0.75 into 100. That comes to 1.125. Then what is the unexpected loss? It is 47.48 minus 1.125. That is the unexpected loss. Right. So it's a matter of deducting 1.125 from 47.48. Then the answer would be 45.923. That is the unexpected loss for the portfolio. Information මේකට නෑ. ඕකේ මේ මෙතන hint කියලා තියෙන්නේ මේ hint කියලා දාලා තියෙන්නේ. sorry. මේකට බුක් වෙන ඕනේ නෑ. මේ hint කියලා දාන්න ඕනේ එකයි පරිවිය මේක. ඉතින් ඒකයි මම දාලා. අතන ඔයා කියන්නේ ඔය hint කියලා දෙන්න තියෙන hint කියලා දීලා තියෙන එක ගැන හොඳට කල්පනා කරන්න. හරි. Right. You get the value, I don't know. 47.48 minus 1.125. That is 47.48 minus 1.125. The answer would be 46.355. Right. Now, have we just did this or done this earlier? A bank has a homogeneous credit portfolio with a total value of rupees 2000 million. There are 300 loans in the portfolio. In normal economic conditions, it records an average probability of default of 1.5%. Economic analysts predicted that in a likely downturn of the economy, the portfolio might report a popular correlation factor of 0.7. Now calculate the 1 year value at risk of the portfolio. If the average recovery rate of the portfolio is 30% at a 99.9 confidence level. Now I don't know whether we did it last time. If not, we can just talk on that. The last one, have you done? I think this can you just do it now at this particular problem? Or have we done it last time?
No, sir.
Right, then we will do it now. I just ask you to just start the things, and 1 year value at risk means now, first of all, you have to calculate WCDR at a 99.9 confidence level for 1 year period. So that there you can use the Vashisek formula here. So just get the formula and just apply the formula. So you will have to calculate, in order to calculate the value at risk, first of all, you calculate the WCDR, that is worst case default risk rate of the portfolio at for a period of 1 year and a confidence level of 99.9%. So just make use of the formula, Vashisek formula, and just do it. Just put down the values onto the formula and just do the calculations. Because you can really do it with me, then you get the skill to work out this type of an example. Right. So then you can say WCDR within brackets 1 comma 0.999 is equal to n. Then you can open the brackets and say n to the power -1, that is minus normal curve into EDR. Now here the EDR is 1.5%. So therefore you can put it in decimal form 0.015 plus square root of rho. Now square root of rho comes as 0.7 rho. That is 0.7 square root of the 0.7 into n to the power minus, within brackets it comes 0.999 divided by 1 minus rho the square root. Rho is 0.7, 1 minus 0.7 is 0.3, so you have to get the square root of 0.3. Now by that you will be in a position to calculate a particular figure, and that figure you have to look at the normal curve table and get the value. So n of that. So that is how this answer comes. It is not a value at risk, you will get the worst case default rate. Can you calculate that? Worst case default rate? Yes. just do it, and I will give you about 5 to 10 minutes to do that. No, I'm really going slow because I know that these things are a little unfamiliar for you, and you need to get the familiarity of these things, get some skills into your hands, like then you will be all right with this, and you can really build up your confidence, and then you can work out these terms, and you can see how the things can be applied in your day-to-day credit management business. It is very much valuable for your organization. Right. We have to just put the formula WCER 1.999 in minus 1 minus 0.1 square root of 7. Now here you have to get the inverse normal curve value of 0.015. Fortunately, you will get that figure as it is on the table. Point 0.0150. I think in another sum also we just get into this value. Point 0.0150. It is there. So it comes in the minus 2.17. Minus 2.17. You need to get the 0.7 square root. .8367. Then the inverse normal curve of 0.999. Yeah, that is also now the figure. The exact figure is on the table, but here you make it a point that you need to get the lowest value for that, not the highest value, because you get 0.9990 in several places. You can get it as 0.08, under 0.08, under 0.09, again 3.1. So there are three places where the 0.9990 is available. So what we need to do is we need to get the minimum value. So therefore you get 3.08. That is the answer for that value. The minus or inverse normal curve of 0.9990 is 3.08. 3.08. And square root of 1 minus 0.7, that is square root of 0.3. That is square root of 0.3. That is 0.5477. And you need to get the value simplified. Now you get for the denominator, numerator, you get 0.4070. In you have to get the value of normal curve value of 7.7431. You can say 0.743. You can get 23 digits. So now you can go to the normal curve tables and just find out 0.743, value of 0.743. .74. When you say 0.743, now you have the value of 0.74 at 0.7704. But since your value is 0.743, so there will be another value, 03. 3 means now between 0.04 and 0.05, you have 30. 0.003 is there, the amount. So if you want to get 0.743, that means it is 0.3 of 30. That is 0.09. So you have 779, sorry, 13. 0.7713. 0.7713 is the answer for this. 0.7713. It is equal to 77.13. Now this is the probability of default, worst case probability of default. But the question is asking, question doesn't ask for the probability of default, but we need to calculate the probability of default, and we need to get the value at risk. And portfolio value is 2000 million. And we have now calculated the worst case default rate at 99.9 confidence level. From that, we are in a position to get the credit value at risk calculator. So we can say the credit value at risk is .7713 into it says that recovery rate is 30%. So loss given default would be 0.7 to 2000. You can get the credit value at risk in millions. You can see the portfolio risk or the credit value at risk is 1079.8 million. It's a drastic amount of a risk or loss. Anyway, so I put on the board the workings. I put on the board. Just look at that. Now this credit value at risk is given here, but before that you need to go through this calculation. Yes. Now this is the calculation for the worst case default rate for a 1 year period, and confidence level is 99.9. that I put as 0.999, and it is the portfolio, the formula is n minus or inverse normal of 0.015 plus square root of 0.7 into inverse normal curve of 0.999 divided by square root of 1 minus 0.7. So if you put it into values, you will have these things. Just make sure that you understand this, and otherwise there's a big high possibility that this type of question might come into your examination. So therefore, it is for your own interest you need to understand these things, because if you don't understand these things now, it is very difficult for you to understand at a later stage. Therefore, you just make sure that you get it understood. Now here the inverse normal curve of 0.015, then you get plus the square root of 7, that is rho, into inverse normal of 0.999 divided by 1 minus 0.7 square root. Then we found the values here. Now inverse normal curve of 0.015 you get as minus 2.17. Then you get square root of 0.7 as 0.8367 into inverse normal of 0.999, you get 3.08 divided by square root of 0.3, because 1 minus 0.7 is 0.3. The square root of 0.3, that comes as 0.5477. And if you work out the numerator, now your numerator, the value of numerator comes as 0.4070. And when you divide it by 0.5477, you get 0.743. And you have to get the normal curve value of 0.743. And it comes to 77.13 or 0.7713. Now you can see how the probability of default go up. In the normal scenario, the probability of default is only 1.5%, whereas this scenario, this is the worst case scenario, probability of default went into 77.13%. That's how many folds increase? Exponential type of an increase, the probability of default. Right. Now with the calculation of this, how are we going to get the credit value at risk calculator? Yes. What should we do? We have to go to the multiplication, that is WCDR into LGD into EAD. So WCDR is 77.13 or 0.7713 into what is the LGD? Because here the recovery rate was given, that is 30%. Since the recovery rate is 30%, LGD is 70%. So then you can say 0.7713 into 0.7 into the portfolio value, that is 2000. You get the credit value at risk as 1079.8 million. Right, that is the credit value at risk of the portfolio. And can you do the next part of it on your own? Or if you have any issues, or if you have any confusing type of things, you let me know. Second part, ask about the amount of unexpected loss. Yes, I think I have just put the things on the board. Now, I don't know whether you got it correctly, or you have the understanding of doing it. Yes, if you have any issues, please discuss. Yes. Yes, anything which you need to clarify? Yes. Now, all these things are okay with you? The calculations, the normal curve values and all? Inverse normal curve values? Are you comfortable with these things? Yes, because I think that I'm little uncomfortable with your non-responses. You're not responding what I am asking, so I'm little uncomfortable with that because I don't know whether you understood it or not. So as a lecturer, I feel very embarrassed when people don't give any responses. Because I might feel all these efforts are in vain.
So it's like this when you are teaching, it's we can understand, but these statistical terms and things are little unfamiliar.
Yeah, yeah.
So
Okay.
yeah, even we are getting the video, then we can see it again. So at
Ah,
when you are teaching, sometimes at once we can't ask questions, so we can't clarify. But when we are
yeah,
going through again, we can get some understanding.
yeah. Anyway, now if you get any type of confusion into your mind, I think then and there you should clarify those things. So when I give time to when I pose for some type of questions and answers, so then you can ask that question. So that is the best thing what you can do. And another thing is I really agree with you because the statistical terms and all that are a little cumbersome and you are not very familiar with those things. But in order to get the things familiar to you, so you need to involve in these things. And that involvement you can get through asking questions. That is what I am telling. Anyway, I feel some people are really at it and they are interested. So what I want to tell you is it is good, very good that you ask such type of questions. And what about this one? Have you got it clearly? And now, are you in a position to do it on your own now? Uh,
Excuse me,
yeah,
sir. Hello.
yeah,
So there you have taken the homogeneous portfolios for that means the as example you have taken housing loans
yeah,
and
yeah,
everything.
yeah,
So but if
yeah,
you take two separate two homogeneous portfolio like personal loans, housing loans, and different types of loans, that
yeah.
they, do we need to calculate the WCDR separately for those portfolios?
Yeah, yeah, of course. Because it's like this. Now you can't get the portfolio as a whole, and then if you have several things there, then you really get into a unrational or irrational type of thinking. So therefore, what it is good if you can uh, just classify the things into homogeneous portfolios. Otherwise, what happens is you will go for a very approximate type of figure which may not give you a correct idea. So therefore, it is better if you can just have portfolios separately. As you say, now if it is a housing loan portfolio, you can uh, very reasonably say that it's a homogeneous one. And when you have a personal loan portfolio, say all are for consumption purposes or whatever, so such loans also can be taken similarly. So likewise, you have to just assure that the portfolio, if you are trying to get this type of a calculation, you need to just classify portfolios into homogeneous types. Otherwise, it is very difficult for you to do a portfolio analysis. Now, at the same time, the correlations also. Now, the assumption is these correlations are similar with each and every loan. So therefore, that is also another big level assumption. So if you have taken a homogeneous portfolio, those assumptions would be more realistic. So that is what I can tell you. As you have that asked that question, so it is clear that you need to calculate the things separately for these separate portfolios. Is that okay?
So Yes, sir. After we taking separate WCDRs, can we? Is it mathematically okay to just adapt and take a
No.
whole WCR value? No.
No. It's not clear. It's not correct because mathematically it's not correct because when you are asking, say, when you are taking the figures, WCDR figures, those figures are not, I mean, say, for example, when you have three portfolios, now these three portfolios, you have three different worst case default rates. But you can't, but this can be done. Now, if you have asked that question that way, now that's okay. Now, what you can do is you can calculate the value at risk for the portfolio by getting the WCDR for that portfolio. And the next portfolio also, you can get the value at risk. Then the total value at risk can be taken as the total of that. I think that really correct when you have no correlations in between these portfolios. If you have correlations in between the portfolio, then that is also not correct. But if you don't have correlations with each portfolio, I mean, if you take the portfolios separately, then you can get the value at risk of those portfolios and adapt. And it can be taken as the total value at risk. So that is a way we can do that. Provided that you don't see any relationship between the different portfolios. Is that clear?
Yes. Yes, sir.
Because you can't add the WCDRs. For example, say you have a housing portfolio, the WCDR is say 20%, and there's another portfolio. It's a vehicle portfolio, and you have a WCDR of say 30%. Then you can't say the WCDR of the addition of housing and the vehicle portfolio is 50%. You can't say that, right? But if you calculate the value at risk by using the WCDR and get the value at risk, say the value at risk of vehicle portfolio is say 200, and value at risk for the housing portfolio is 300, then altogether it would be 500. That can be taken, but provided that the two portfolios don't have any connection. But after calculating the value at risk, you can add that. But there also, you have to assure that there's no relationship between the two portfolios. That means the housing loan portfolio and the vehicle portfolio do not have any relationship. If that is the case, you can take the total. Is that clear?
Yes, sir.
Right. Now we will just go into a little different thing here, and that comes to the individual type of advances and in a portfolio, within a portfolio. So we just last time we did a presentation on unexpected loss of particular loan. It is simply one loan, right? So the unexpected loss of one loan we calculated. So we will go to that presentation and I will show you that, because it gives you a certain meaning. Right. Now just look at this presentation. Before coming to this first case default rates and all, we got into a slide where you can calculate the unexpected loss of a loan. That's an individual one. Portfolio unexpected loss. Oh, before going into portfolio, you need to see how you can get the individual loans unexpected loss. Now, I think we did it earlier. Now here, the notation is very important, right? Now, when you say the unexpected loss of one loan, this is another way of calculating that. Now, what we did was, we did some assumptions and we went through the Vasicek model and we calculated the unexpected loss of the portfolio. But here, what we can do is, we can calculate each unexpected loss in a different way. There's a different manner. And do the total unexpected loss of the portfolio by looking at different loans and their correlations. But what happens here is, in our Vasicek's model, what happened was, now here we have taken only two loans, 1 and 2, where the correlation between asset 1 and 2 is taken as row 1, 2. But in a portfolio, you might have about 100 loans, more than 100 sometimes. But these 100 loans, in the Vasicek model, we assume that all the pairs will have the same correlation. But in reality, it is not the case. Then if you don't assume that, then you have to realize these things in a separate way, as I told you earlier. Because the Vasicek model, the assumptions are little unrealistic sometimes. Now, the first assumption is all the loans in the portfolio will have the same probability of default. That is one assumption. The other assumption is all the loans will have the same correlation. All pairs of loans will have a same correlation. Now, in this case, I want to show you, now this is a little difficult task, but if the assumptions are not realistic, then there's no other way. We have to go through this method to calculate the unexpected loss of a particular portfolio. So it's not an easy one. It's a little difficult one. And we need to have some parameters also identified. Now just look at this equation. UL1 is equal to AE1, that is the average exposure, into the square root of EDF, that is the average expected default frequency, then into the volatility of LGD, or the standard deviation of LGD squared, and LGD again, that is squared, it is not the standard deviation, it is LGD squared into square of the standard deviation of EDF. So that is how the UL1, or unexpected loss, is calculated of asset 1. Now you might ask the question, if I calculate these unexpected losses of the portfolio, then it can be like this. You can calculate this number 1 assets or number 1 loans unexpected loss as UL1. Then what is the second one? Second loans unexpected loss is UL2. Third loans unexpected loss is UL3. Fourth loans unexpected loss is UL4. Likewise, you have to have that type of loans. And here we don't have an assumption to say that the correlation between 1 and 2 is same with correlation between 2 and 3, and same with 3 and 4. That assumption is not here. If that is the case, you need to understand how we are going to get the portfolio unexpected loss. We don't have the Vasicek's models assumptions. And since I can remember that some person asked me, is it realistic or it is rational to take everyone's probability of default is same? So therefore, if you don't assume in that manner, there's no other way rather than doing this. But this is a little cumbersome type of thing than that. right? Anyway, now I will show you. If you just calculate the UL1, UL2, UL3 and so on and so forth, then how are we going to get the portfolio risk or portfolio unexpected loss calculated, right? I'm just now trying to do that. Now you can see the upper level ULP is given. That is a portfolio's risk, unexpected loss. So there's another assumption. Now you have only 2 loans in the portfolio. Now you just look at it and see how it is been calculated. UL1 squared plus UL2 squared plus 2 row 1, 2 into UL1 into UL2. So this is the way it can be calculated. Now that gives you the portfolio expected loss. Not the expected loss, the unexpected loss, sorry, unexpected loss. That clear? Now I can just show you, say, I am referring, if I refer to 3 assets in the portfolio, now how can it be now? I will explain those things on the board. Now, in the case of this variance, so sigma squared of LGD1, that is the square of standard deviation. So there you need to think that LGD is a variable, loss given default, and it has a standard deviation also. And then in the same manner, you think that EDF is also a variable and you have a standard deviation of EDF and you have to get the square of that standard deviation. Now we call it variance. We call it variance by the way. Square of the standard deviation is called variance. Therefore, in this formula, it is taken into consideration the variance of LGD1 and variance of EDF1. In addition to EDF1 and LGD1. So that is what you need to understand. Right. And this is UL1. This is only one loan. And if you take UL2, there also you can have the same type of formula to say that UL2 is equal to AE2 into EDF2 into square LGD2 square of standard deviation plus LGD2 squared into variance of EDF2, sorry. So that is UL2. And in this case, you calculated UL1 and UL2 both. And when you know UL1 and UL2, and you should be in a position to calculate the portfolio unexpected loss, assuming that these two loans are in the portfolio. That can be valued or that can be taken as ULP is equal to square root of UL1 squared plus UL2 squared plus 2 rho 1 2 into UL1 UL2. So that is how, now I think one person asked that question also. Are we in a position to get these things WCDR calculated and get the algebraic total? So that is not the way. I think if you want to get the total, you have to do it this way. Since we are talking about risk, not in normal terms. But expected loss, if you calculate it, really you can calculate the individual expected loss of all loans and get the total loans expected losses added up, and that would give you the total unexpected loss for the portfolio. But in the case of unexpected loss, you can't do that. In the case of unexpected loss, you have to calculate. There's a calculation for that, and it has a certain formula. Like now, I will show you how to by heart that formula. I think you need to by heart because if you go into an examination, most of the time these formulas may not be given. But I think this UL1 formula and all, I think that you might get it. However, some of the very famous formulas may not be given in the question paper. If you have some not that familiar and not that regularly taken formulas, I will give that even for the examination. Now I will show you how you find out the number of pairs of a particular portfolio, given the number of, if you know the number of loans in the portfolio, you will be in a position to arrive at the number of pairs in that portfolio. So that's a very good information you can make use of. Right, I will show you. Right. Now let a particular portfolio contains 1, 2, 3, 4. So there you have loan number 1, loan number 2, and loan number 3 and 4. Now, how many pairs you can make through these 4 loans? So what is the answer you can give? How many pairs? You can just look at the way it can happen. You can have a pair of 1 and 2. We can put it as 1, 2. You can have a pair of 2 and 3. You can put it as 2, 3. And you might have a pair of 3, 4, or 3 and 4. That is 3, 4. Now I told you, you have 1, 2, 2, 3, 3, 4. Not only that, then you have 1, 4. Sorry, 1, 2, 2, 4 and 4, 2, 3 and 3, 4. I just gave earlier. Then you might have 1, 3, 1, 4. That also is a possibility. So then how many would you take? Of course, there's a very simple formula you can make use of and get the number of pairs in a portfolio of number of loans. What you need to do is, you need to have a formula called n into n minus 1 divided by 2. N is the number of loans in the portfolio. For that, say, if you have 2 loans in a portfolio, you can work out the formula and see whether it is correct. When you have two loans in a portfolio, how many loans pairs you have? 2 pairs. Since 2 loans are there. Sorry, 2 loans are there, only 1 pair. A and B. Only AB you can have. BA also you can say, but it is not separate one or the same pair. So it is AB. Only 1 pair with 2 loans. If you have 3 loans, there will be how many pairs? You should have AB, BC, AC. Then how many? There are 3. Now we will see whether these things agree with our formula. Now as per the formula, what we need to do, n into n minus 1 divided by 2. Now in the case of 2 loans, you have 2 into 2 minus 1. 2 into 2 minus 1 is 1, divide by 2. Then what is the answer? You get the answer as 1. So therefore, if you have 2 loans, you have 1 pair. If you have 3 loans, so then how you can get the formula applied? 3 into 2 divided by 2. So then 2 and 2 cancel off. Then the answer would be 3. So therefore, when you have 3 loans in the portfolio, you have 3 pairs. You have 3 pairs. So likewise, when you have to calculate when you have 5 loans in a portfolio, how many number of pairs would be there? How many pairs would be there? So how are we going to get it? 5 into 4 divided by 2, that is 5 into 2, 10. There are 10 separate pairs in that portfolio. Since you have 5 loans in the portfolio, then how many pairs you will have? 10 pairs. So likewise, by making use of the formula, you are in a position to say that if you know the number of loans in a portfolio, how many pairs you can make through those loans. So that you can get through the formula. I will put the formula on the board. N into n minus 1 divided by 2 is the formula where n is the number of loans in the portfolio. The answer, I don't know whether you can see that. Anyway, I will put it somewhere else. N into n minus 1 divided by 2. So n is the number of loans in the portfolio. Right. Now I am asking these, you can consider it as a quiz like. So if I say your portfolio, in your bank's portfolio, there are, say, 100 loans. If you have 100 loans in the portfolio, how many pairs of loans there? By applying the formula, you can arrive at the figure. Yes, what is that? If there are 100 loans in a portfolio, how many pairs of loans there? Couples of loans. By using the formula, you can arrive at the figure. Yes.
It's 4,950.
4,950, yes. Because how you can put it? 100 into 99 divided by 2. So 100 into 99 is divided by 2 is 15 to 99. 15 into 99 is 15 to 100 minus 50. So 15 to 100 is 5,000. 5,000 minus 50 is 4,950. That is the answer. Now you can see when you have 100 loans, how many pairs you will get? 4,950 pairs you will get. So that all of those relationships, and you will have 4,950 correlation coefficients there. So how complicated that? How it is complicated? You can just see what are the complications coming on. Now that is why in our Vasishek's model we had that assumption at a time of normal economy or in a very drastic economic downturn. What will happen is there will be similar correlation coefficient for all the loans. But in realistic situations, what happens is there can be several several types of correlation coefficients available in the portfolio in a normal scenario. So therefore, our assumptions are basically unrealistic sometimes. But if you go by the realistic assumptions, or realistically if you go into this, then your quantifications would be difficult. And you have to follow complicated procedures to do that. That is the issue. But anyway, even though complicated, it's possible to arrive at the figures. Now I have given here a formula. That formula is about the unexpected loss. So each and every loan would have EDF, would have an LGD. Therefore, you can calculate these values for individual loans. Not only that, you need to know the correlation coefficient between these two loans, return of two loans. So if you know that only, you are in a position to get the portfolio risk calculated. Any questions on that? Now, this methodology has to be used when you don't have the assumptions to work out the portfolio risk through Vasisek model. Because Vasisek model is applicable only for the portfolios which can follow the assumptions. What are the assumptions? In a downturn type of situation, the correlation coefficient will be equal with each pair of loan. And probability of default also the same for the each and every loan in the portfolio. Now these are the assumptions in Vasisek model. Whereas if you can't assume that way, then you have to go individually by loans, and using the formula you have to calculate the individual loans loss, and you need to calculate the portfolio's unexpected loss by having a formula, because it is not the just adding up. You have to make use of formula to get the portfolio risk. Portfolio unexpected loss, we call it. Now we can work it out to some extent. I will keep the formula on the board. Now the board formula and this is the same, but this has a more formal way of putting it. Right, I have just put the value on the board. I do just look at the chart. Now I just put loan 1, loan 2, and loan 3, assuming that there are 3 loans in the portfolio. Now just look at the board and see. Start loan number 1, the average exposure is 300. Then sigma squared LGD, that is LGD's variance is 0.2, variance of EDF is 0.4, LGD is 0.4, and EDF is 0.02. And if you take loan number 2, there you have AES 400, variance of LGD is 0.3, variance of EDF is 0.6, LGD is 0.3, and EDF is 0.04. And loan number 3, AES 500, variance of LGD is 0.4, variance of EDF is 0.7, LGD is 0.2, and EDF is 0.05. Now, try to get the unexpected loss of loan number 1. Unexpected loss of loan number 1, UL1. Yes, try to get it through the values given here. Just to calculate, because the formula is given, UL1 is equal to AE1 square root of EDF1 into sigma squared LGD1 plus LGD1 squared into sigma squared EDF1.
So the numbers are not visible in the table. Can you repeat the numbers again, please, in the table?
Right. Okay. I will read it. Now, in the rows, you have loan number 1, loan number 2, loan number 3. The other side, you get AE, sigma squared LGD, sigma squared EDF, then LGD and EDF. So, loan number 1, AE is 300, sigma squared LGD is 0.20, sigma squared EDF is 0.4, LGD is 0.4, EDF is 0.02. Then you go into loan number 2. AE is 400, sigma squared LGD is 0.30, sigma squared EDF is 0.6, LGD is 0.3, EDF is 0.04. Then loan number 3, AE is 500, sigma squared LGD is 0.4, sigma squared EDF is 0.7, LGD is 0.2, EDF is 0.05. Now these are the values. I think you have followed now that. Then underneath you have row 1, 2, that is the correlation coefficient between 1 and 2, that is 0.2. Then row 2, 3, that is correlation coefficient between 2 and 3 is equal to 0.3. And last one, row 1, 3, it is equal to 0.4. So those are the values. I think to be clear on that, I just read all these things. Now, first of all, what you need to do is you need to calculate the loan number 1's unexpected loss. Anyone who got the value for unexpected loss of loan number 1? Now, first of all, you have to get EDF 1, that is 0.02 into sigma squared LGD 1, that is 0.2 as per the chart, plus LGD squared 1 square, that is LGD is LGD is 0.4, 0.4 square into EDF sigma squared EDF, that is 0.4. Now, when you work it out, you get 0.068 and you have to get the square root of that. It comes to 0.260 and it has to be multiplied with 300. You should get an answer 78.23. Have you got that? $78.23. That is the answer for the loan number 1. That is the unexpected loss for loan number 1. 78.23. So, Now we will do the calculation for loan number 2 also. Yeah, the answer you would get 102.76 on number 2. UL2 is equal to 102.76. Then we will go to the loan number 3 also. For your loan number 3, you get 109.54. Now, if we want to get the portfolio unexpected loss calculated, I will give you a formula. That formula is not in the slide. I just put it here. Formula for 3 loans. So that will come as this. ULP is equal to square root of UL1 squared plus UL2 squared plus UL3 squared plus 2 rho 1 2 UL1 UL2 plus 2 rho 1 3 UL1 UL3 plus 2 rho 2 3 UL2 UL3. Now all these square. So this will be the formula for 3 portfolio with 3 loans. Because now you have calculated UL1, UL2 and UL3, and you have the row 1, 2, row 2, 3 and row 1, 3. Because of that, you are in a position to calculate the portfolio loss, unexpected loss. Yes. Have you just got the values correct? Now, what I want to tell you is this particular calculation I have given to give you a certain way out. If you are not in a position to assume that in a scenario where your portfolio probability of default is same with each loan, and the correlation is same with each pair of loans. If you are not in a position to come into that type of assumptions, invariably you have to do this. That is the way out for such type of situations. If you think that, as you have asked me the questions now, you think that those assumptions are not realistic, then invariably you have to adapt this method to calculate the unexpected loss of the portfolio. Now, when you say board is not clear, right, anyway, this I don't know whether you can get my readings correct. Can you? I think even though the things are not very clear, you can see it's a schedule like that you can see, you know, because I just gave it loan number 1, loan number 2, loan number 3. Those are the rows of the schedule, and columns being given as AE, sigma squared LGD, sigma squared EDF, LGD and EDF, right? So then I have given the values. In the first row you have 300, 0.2, 0.4, 0.4 and 0.02. In the second row you have 400, 0.3, 0.3, 0.6, 0.3 and 0.04. In the third row you have 500, 0.4, 0.7, 0.2 and 0.05. And in addition to this, I just put the formula on top. That is UL1 is equal to AE1 square root of EDF1 into sigma squared LGD1 plus LGD1 squared into sigma squared EDF1. So that is the formula given on top of that. Right. Now I tried to just explain something on the board, but these things are available in the slide also, but not the schedule. But I think the schedule I read now. So with that, you try to just do the calculations as it is. So I think we are not in a position to proceed further now because it's almost the time has passed. Anyway, anything which you need to clarify? Right, with that, we just wind off the class. Thank you very much for your last formula. Oh, yeah. Wait. Now ULP, that is the portfolio unexpected loss, is equal to UL1 squared plus UL2 squared plus UL3 squared plus 2 row 1 2 UL1 UL2 plus 2 row 1 3 UL1 UL3 plus 2 row 2 3 UL2 UL3, the whole thing squared, whole thing square root. So that is the formula. I think that is that could be clear enough. Okay. So with that, I think we can wind off the class, and you can work it out and see what is really happening. And next time we will discuss about that. Thank you very much.